Alright guys, this video is going to be about solving linear equations. So remember that we are in Chapter 3. This is for Math0309, which is the business statistics class. And I want to be very clear, I hope that you are trying some of the problems out on Connect Math, just to make sure that you're staying on top of what skills you need to be comfortable with. But I'm going to do just a couple of problems in this video that are probably just a little bit more challenging than maybe the ones with Connect Math. So remember, this is coming from section 3.3 and 3.2. So these problems come from page 161 in section 3.2. And I just want to remember this is a combination of things happening. Alright, so in this case, we're solving for y. And as you can see, I have two sets of the distributive property, and that's where we start. Okay, so remember I tell you to draw arrows to show that you're multiplying that 2 through to each individual term. Alright, then we're also going to do the same thing here in this parentheses. And always remember to watch the signs. Okay, so in this case, let's drop down the minus 5y. And then 2 times 2y is 4y. 2 times 1 is 2. Drop down our equal sign. Remember, always move from left to right. So we're going to do 2 times 5y, which is 10y. But 2 times negative 1 is negative 2. And then I'm going to drop down the minus 7. Now remember, I talked about when we did integers that if you would like to, you can change that minus to a plus and then bump back the negative so that you can see you really have negative 2 plus negative 7. Alright, but let's just start back left to right. So in this case, I have a negative 5y plus a 4y. So these are opposite signs. I'm going to subtract and keep the sign of the bigger number. So this is going to be a negative 1y. But I'm going to just write negative y. Drop down the 2, because again, I could only combine these two terms. Drop down my equal sign. Now over here, I can't do anything to this 10y. But then negative 2 plus negative 7 is negative 9. You add because they're the same sign. And now remember, I always say letters to the left. So letters left, okay, and then numbers right is my other one. And I should have wrote this on the left side, but it's okay. So we're going to move the letters to the left side. So I'm going to, remember this is a plus 10y. I'm going to change it to a minus 10y because I do not want it on the right side of my equal sign. What I do to one side, do to the other. So now, again, this cancels out for 0. Okay. And now what I do is, if you would like to put a plus sign, draw a line all the way across, we're going to combine these two terms. So remember, this is a negative 1y plus negative 10y. So we'll add those together, negative 11y. Drop down my 2 equals, and we have a negative 9 on the right side. Okay. Now I'm going to put my numbers to the right. And this is just a rule of thumb, but you don't always have to do that. As long as you get your variables or your letters over to one side of the equal sign and get your numbers and constants over to the other side. So we're going to minus 2, that cancels out. And now what we have on the left side is negative 11y is equal to, remember you're adding, this is negative 11 on the right side. And the last step is, after you now have your letters over to one side, you have your constants on the other side, you always divide by the coefficient and its sign. So we're going to divide by negative 11 to both sides. That's gone because that's a 1. And so now the final answer, y is equal to a negative divided by a negative is a positive. Alright, and 11 divided by 11 is 1. So here's the final solution to that problem. Okay, let's keep going. Alright, so here's another problem from section 3.2. As you can see in this case, I have 3 distributive properties that I have to do, and then we got to combine like terms, and then of course isolate our variables to one side, our numbers to the other side, and solve for our unknown variable, which is a. We're trying to figure out what is a. So I'm going to draw my arrows to show the distributive property. Every time you see a number in front of a parentheses, you have to multiply that number to each individual term in the parentheses. Okay, so remember, always keep the sign, and remember your integer rules. So negative 2 times 4a, this is negative 8a. Negative 2 times 3 is negative 6. Negative 5 times 2 is negative 10. Negative 5 times negative 1a, that's a positive 5a. Okay, we're done with that side. Now we'll put our equal sign. 3 times 2a is 6a. 3 times 3 is 9. And then we drop down that minus 7 in the back. Okay, so now we're going to, after we've done all the distributive property, let's do combining like terms. So if you want me to make a note there, I can. So we're going to combine like terms. Can't see the wording. Combine like terms. So this is where we look at both sides of the equal sign and we try to figure out, if there's anything we can combine. Okay, so in this case, I have a negative 8a here. I have a positive 5a. Notice that I circle the signs in front of those two terms, so I know that I have to include the sign in the operation. So I have negative 8a plus 5a, so opposite signs we're going to subtract. Keep the sign of the bigger number, so this is negative 3a. And now I can also combine this negative 6 and this minus 10, so that's negative 16. Drop down my equal sign, and over here on the right side we can combine this 9 minus 7, which will give me a 2. So 6a plus 2. And again, I'm going to just do this to be transparent. So I'm going to put letters left, and here I'm going to put numbers on the right side. Numbers right. Okay, so I'm going to do this all in one step just to kind of save some time. So I'm going to move this term over again to the left side because I want all my letters to go to the left. So I have to change the sign, minus 6a, that's done. And then remember you're adding, so this is a negative 9a here. Okay, and then I'm also going to change the sign on the 16 and move it to the right side, which will give me, this is gone, which will give me an 18. So drop down your equal sign and 18. I can't stress enough to be very careful with your arithmetic and being very consistent in how you move everything around, and watch your signs and drop your equal sign down and be really careful. Okay, so in the last step, again, I had my negative 9a here, had a positive 18 on the right, but I divided by the coefficient and its sign, which gives me a 1 here. So this is a equals 2, and again this is negative 2 because a positive divided by a negative is a negative, and 18 divided by 9 is 2. So the answer is negative 2. And if we wanted to go back and check, we just go back to the original problem. We plug in negative 2 here, negative 2 there, negative 2 there, and we would just try to see if both sides are equivalent. And this would be the right solution. But we don't have time to check, okay? So that's 2 problems from 3.2. Let me see if I can find a couple more. All right. Okay, so we're going to keep going. Let's see. Let's do some now with fractions. This is also from page 161. So I have 3/7 x minus 1/4, excuse me, negative 4/7 x, and then we have a negative 5/4. Okay, so when we have fractions, remember the key to this is to multiply by the common LCM. Remember, least common multiple. So we're trying to think about the 7 family and the 4 family, and we think, what number do they have in common? What multiple do they share? Well, the answer is 28. Okay, so we're going to multiply this entire equation by the number 28 to every single term. So I'm going to draw some arrows to every single term. Okay, now I just want to make a really quick note that some people do this, and I just want to stress why this is not the proper thing to do. So let's go back real quick to this problem here. Notice that this negative 2 is only to be multiplied by these 2 terms in the parentheses. You cannot take that negative 2 and distribute it all the way over to this negative 5, or in here, or all the way to the other side over here with these terms, okay? But in this case, I am multiplying 28, as you can see, because I put the parentheses over the entire equation by every single term. All right, so just wanted to show that you cannot always do the distributive property to every term, but in this case, this is going to help us to clean up our fractions, okay? All right, so this is the way that I do it. You can do it the longer way, and you could do some scratch work, and you could say, hey, 28 over 1 times 3 over 7, okay? And if you wanted to just multiply across, you could do 28 times 3, get a very large number, which I believe it would be 84, I want to say, over 7. Okay, then you would have to do some division and find out the answer is 12. Okay, but what I like to do, and you could also do this trick, you could reduce diagonally. 7 goes in here 1 time, 7 goes in there 4 times, and as you can see, 4 times 3 would be 12 again. But the way I do it is I just do it all in one sitting with no scratch work. So I just tell myself mentally, 7 is going to divide into 28. It goes in there 4 times. I store that number in my mind, 4, and then times the numerator. Okay, so 7 divides in here 4 times, and then 4 times that numerator, there's that 12x, okay? So the first term is 12x. Now we don't have a fraction anymore. Now it's this guy's term, all right? I'm going to do 4 dividing into 28 again, and it goes in there 7 times, but then I say 7 times -1. So this becomes a -7. Okay, and then I write my equal sign down, and I'm doing it again. 7 divides into 28 4 times. 4 times -4 is -16x. And the last one is 4 divides into 28 7 times. 7 times -5, here's -35. And as you can see, now we've cleaned up that problem to not have any more fractions. We now have nice whole numbers. And I'm going to do my letters to the left, numbers to the right. So I'm going to move the 16 over to the left. Okay, what you do to one side, do to the other. So these add together for a 28x over here. I'm going to move my number over to the right side, but you have to change the sign first. What you do to one side, do to the other. So this cancels out. Drop down my equal sign. And again, we're going to subtract these two, and we should get -28. Yes, -28. And of course, we're still trying to solve for x. So we're going to divide by 28 to both sides. And so this will divide in there 1 time. So x is now by itself. This is a -1. So the answer to this one is x is equal to -1. Okay. Let me find one more with fractions. See if I find something a little bit more trickier. Okay. Alright, I found one more, but it doesn't look as bad. Okay, so let's do one more fraction, then let's do decimals, and then we'll just make this a short video and move to 3.3. Alright, so in this problem, it has 5/6 x plus 2/3 is equal to -1/6 x minus 5/3. Okay, so for this problem, of course, the obvious answer is 6, not 18, okay? Because I want to be clear, some people don't understand how to identify the LCM, okay? Don't ever choose a number smaller, you know, like in this case, don't say 3. Don't choose 3 because, again, 3 is not in the 6 family. Now, you're not wrong to say 18 because, again, 18 is in the 3 multiple family and 18 is in the 6 family, but again, you want the least common multiple, all right? So in this case, we could just use 6 because, again, 6 is in the 3 family and 6 is in the 6 family. So let's multiply everything by 6. So we're going to do the distributive property to every single term. So you can go across that equal sign. All right, so 6 divides into 6 1 time, so this will be a 5x. 3 divides into 6 2 times, and then 2 times 2 is 4. 6, of course, divides into 6 1 time, and then 1 times -1 is just going to be -1x. So we'll just put a -1x here. 3 divides into 6 2 times, and 2 times -5, -10. There it is. So now again, letters to the left, numbers to the right. So I'm going to add this 1x over to the left. It cancels out that term on the right side. This becomes 6x. I'm going to subtract 4. Subtract 4. That goes away, and now I have -14. Now in this case, as you can see, you know, 6 does not divide into 14 evenly, okay? So we got x is equal to, we have a fraction, but of course we can reduce this answer. So we have -14 over 6. These are both divisible by 2, so we would get -7 over 3. And that's the answer right there. Okay, is this -7/3 is our x. All right, so that should be pretty good for fractions. I hope that you can tell you know how to identify the LCM. All right, I'm going to do one more. Okay, guys, I wanted to do problems on decimals, so let me start with this one. Okay, so we have 3 being multiplied. Of course, you got to do the distributive property to this 0.9n plus 0.5, and then you have negative 3.5n plus 1.3. All right, so we're going to do our 3 being multiplied to these 2 terms here. And so if you do your scratch work, okay, you do your 0.9 times 3 over to the side, you're going to get 2.7. So 7, carry the 2, 0 plus 2, and then remember you swing 1 time, so you swing into your answer 1 time. Okay, so that is a 7. This is a negative 2.7n. And then I already know half of 3 is 1.5, so plus 1.5. And then I'm dropping down the terms that are over on the right-hand side. All right, so I'm going to do my letters to the left, my numbers to the right. So I'm going to add 3.5 n over to this side, which means I'm going to end up subtracting these 2 values. And then I'm going to subtract 1.5 over to the right side. And I'm just doing this in 2 steps just to save some time. Okay, so when you subtract 3.5 minus 2.7, okay, remember to line the decimal up. So we're going to borrow from the 3, make it a 2, make this 15. So this becomes 0.8 because 15 minus 7 is 8, and then 2 minus 2 is 0. So this is going to be a positive 0.8 n. This is gone from the left side, so we'll put our equal sign, and then we're going to subtract these 2 and get negative 0.2. Okay, so now we're going to divide by our 8/10 to both sides. So n is equal to, now I already know that a negative divided by a positive is a negative, and I'm going to do my T-bow. So I'm going to do my 0.2 being divided by 0.8, and I'm going to swing 1 time here, swing 1 time here, and then I'm going to rewrite. So that becomes 8 dividing into 2.0. Bring this 2 up there. I'm sorry, the decimal point, raise it up. And 8 can't go into 2, but 8 goes into 20 2 times for 16. Subtract for 4, bring another 0 down, and 8 goes into 45 times with no remainder. So the answer is negative 0.25 for n for this one. Okay, let's do one more with a decimal. Okay, so this next one is 7 times 0.4m minus 0.1. And then we have 5.2m plus 8600ths. Now, listen very carefully. Some people ask if there are tricks with decimals, and there actually are, okay? So what you could do is after you complete your distributive property, or even before you do the distributive property, because these numbers, let me recorrect myself. This last problem, because everything has, you know, a 0.9, so there's a 9/10 here, a 5/10, a 0.5, and then a 0.3, we could have multiplied everything in this entire equation by a 10. And what that would have done is made it to where we don't have to deal with decimals. Each one of our terms, even this number here, would all increase by a magnitude of 10. So this would change to 30. This would change to 9 because, again, you're multiplying by 10. So essentially, it's swinging the decimal a magnitude of 10. So all these decimals would swing back and become 10 times greater. So this would become a negative 9n, a 5, a negative 35n, a 13, and then this would be a 30. Okay, then you would redistribute this 30 and then have everything clean with whole numbers. But we're trying to stay true to just dealing with decimals because all those skills have to be well-rounded for us to be good math people. Now in this one is a little different, okay? You notice you have your 4/10, you have your 1/10, you have your 5.2, your 2/10, but in this one there is a 0.86, so this is 86 hundredths. So in this case you would not multiply by 10 to every single one of these terms, you'd actually multiply by 100. Why? Just because this one decimal has a hundredths place. Because if you multiply everything by 10, yeah, that becomes 70, that becomes 4, this becomes 1, this becomes 52, but this would change to 8.6, okay? So if you want all of them to be whole numbers, then you have to multiply by 100 to each term, all right? Which they show that in section 3.3, so I'm getting a little ahead of myself, but these are just things I threw out there and then I noticed it was in the book. But let's stick with decimals, okay? So I'm going to do this 0.4 times 7, my scratch work over here on the side, which would be 28. This would be 0 plus 2, and then swing one time to my answer. So this becomes 2.8n. And of course this is just a negative 0.7, and then we'll drop down these terms on the right side. So again, maybe just from this step is where we would say, oh yeah, let's multiply by 100, and then essentially all these numbers would swing 2 places. Okay. Alright, so back to this problem. I'm sorry. We almost ran out of space. Alright, so again, all I was saying was about the multiplying by 100, but we're just going to stick with decimals. So let's move this 5.2 to the left side. We're going to add 0.7 to the left side, add it to the right side. Notice how I'm lining those decimals up for the addition, and this term is gone. So now I'm left with, we could put a little plus sign. And again, these are opposite signs, so I'm going to subtract. So I'm going to come over here and do a little bit of scratch work on the side, just so I can see. Be careful with that, because some people take for granted that, oh, I can do it mentally. Don't do it, okay? So I can't take 8 away from 2, so I'm borrowing, make this a 12. This becomes 12 minus 8, which is 4. Drop down my decimal, and so this becomes a 2.4, but it's a negative 2.4, m. Equals, and then in this case we're adding, so we should get 6 here, then we have a 5, carry a 1, so this should be 1.56. And now I'm dividing by negative 2.4 to both sides. So m is equal to, I'm going to do my T-bow. Okay, so we'll put 1.56 on the inside, put our 2.4 on the outside. Again, I know it's going to be negative as my final answer. Swing one time, swing one time, and now I'm rewriting. So this becomes 24 being divided into 15.6. Bring the decimal up, goes in there 0 times 156. And scratch work, I've done it previously, but I think I should do 24 times 6 to try that out. And that gives me 4, 2, that's 144. If I add another 24 to this, I'll get 168, and I'll overshoot it. Yep. So let's go 6 times for 144. When I subtract here, I'll get 12, bring down a 0. And 24, if I take it away from this, it'll give me a 120 if I subtract 24 from here. Let's just check. Yeah, so it's going to go in there 5 times. For 120, no remainder. So the answer to this is negative 0.65 for m. Alright, so that takes care of a few problems with decimals. And the last thing that I want to just throw in here super quick is going to be what happens when there is a negative in front of a parentheses. So let's just say you have something like, let's see, sorry for the screaming, it is spring break. So I have 8 minus 3q plus 4 equals 6 minus q. So there's a negative 1 here. Do the distributive property, and I have 8 minus 3q minus 4, 6 minus q. And I'll combine like terms. This is going to be a positive 4 minus 3q equals 6 minus q. And then I'm going to, in this case, remember it doesn't really hurt, you know, but I can move this letter over to the right, and I can move this number over to the left. But in this case, I'm going to just stay true to moving my letters to the left, numbers to the right. So 4, now remember there's a 1 here, so we're going to subtract and get negative 2q. There's a 6 there, minus 4, minus 4. So I have negative 2q is equal to 2. Divide by negative 2 to both sides. So q is equal to negative 1. And that is the end of this video. So again, guys, this is about distributive property. It's about dealing with fractions, and make sure that you can clean fractions up with least common multiples or least common denominator. Combining like terms. Be careful with your distributive property, and we'll be having our test probably 2 weeks after the break. Alright, so I'm going to shoot one more video, and hopefully these are helpful for you guys. Alright, take care. And in this one, let's look at decimals, okay? So